Alright, time for another draft science video presentation. Yeah, I said it right. Draft physics on the internet, but not updated the website, so not the best location. But anyway, I have to work. So lots of things to do, only one person to do them. So, it's a lot. Anyway, a lot for me. So, alright, Google first. So let's do the story of the DMCA, right? This piece of legislation that was actually well intended in the sense that there was a problem on the internet where obviously if ISPs are companies that provided you the ability to speak, if they were being held accountable for what people were speaking. And so this was sort of a problem because obviously they don't want to be responsible for what the people are saying. So then they're going to censor them because they're going to say it's not in our interest, to have a liability to provide the service of being able to speak, that kind of thing. And there was also the copyright issue. This legislation was essentially going to fix both of these problems, where the ISP wouldn't be held responsible for the behavior of its users. Now, clearly on the copyright issue, it sort of failed right from the beginning because obviously companies like Sony or big producers couldn't afford to protect their copyright because now they had to sue a bunch of individuals, and it's expensive suing individuals. And you don't get anything for your trouble because you can't just say, well, here's the cumulative amount of value they've destroyed, these people, and when you could just sue YouTube for the copyright infringement, you had some chance of getting properly compensated because you only had to file one lawsuit for the entire loss rather than 500 lawsuits for a little bit here, a little bit there, a little bit there. So it was totally impractical as a solution, and they never decided to fix it, and so Google fixed it on their own. And they fixed it by just ruining the whole concept of fair use that was supposed to be protected. So they just pre-censor us, exactly what the law was intended to stop from happening. Google presumes you guilty, and there's just no way to fight back. Now the part that kind of sucks is small producers like me who have their content out here. We can't really protect somebody, stop somebody from unfairly using it. That is, not using it for educational purposes or to enlighten or do something like that. They just buffoon it. That is, they just put Hitler mustache on you or some kind of horseshit like that. And so that commentary isn't protected under fair use. You have to draw a picture of me and put a Hitler mustache on it if that's what you want to do. But you can't take my copyright material. You can't take material I still own. And the default is I own it until somebody says I don't own it. Okay, so until I say you can have it, you can't have it for free. And you have to have a fair use. And like I said, fair use is rational use. It's not irrational use. So you can't use it to slander somebody. That's the limitations on your use, is that there has to be some reasonable purpose you're attempting to accomplish, and if the purpose is to harass or to invade privacy or to make accusations for which you can't defend, then it's not fair use and you're violating the law and blah blah blah. But the problem is like I said, the small producer can't really protect his content because he has to go to court then. His only option is court. And so YouTube pretends like it's obeying the law, but now the catches they've added is that for the small user, YouTube's presumption is that you're some kind of company and you don't mind having your name on there. So they're going to use your real name when you say he's violated my copyright. They're going to take the video down and put your name up and say you claimed a copyright. But they're not going to use your screen name by default. They're going to use your real name. So they're going to dox you when you attempt to protect your content. So why do they give you screen names in the first place if they're not supposed to mean anything? So it really doesn't make any sense. But again, it's, Google they're violating the law because the law basically is intended, and the intent of the law is to prevent the very thing they're doing, which is prejudging content. They're not supposed to make a determination that we think it is or we think it isn't. they're supposed to, okay, provide a mechanism for accountability, and they're giving all the protection now to the big producers in the sense that you're presumed to be guilty, and you first have to prove your fair use to Google, essentially. They'll take your stuff down for 10 days, and frankly, they'll take it down forever. But anyway, we won't even get into that, because you can't realistically defend it as fair use. They won't let you. Just a fact. Or else they'll just automatically slam a commercial on it, as if you authorize that. So it's just bullshit. So anyway, the function of the law is to do certain things, and none of those things are really being done by it. So they need to fix it, but there's no energy. No one cares enough to say, you got to fix this, because this really isn't good enough. And clearly in the case of the malicious uses of stuff, they need to create some sort of law where you don't have to go through some idiotic, huge legal procedure to merely point out that somebody's not really doing fair use. They're not exposing the truth. They're creating fake news. They're making accusations that they don't have any reason to make, except to cause a person to have to defend themselves against them, to waste their time, pointing out how it's not accurate. And that's not the function, shouldn't be the function of any of the civilized mechanisms we have, where you can just make accusations without having any substance or any value or any, they have no integrity. Alright, so that's enough of that, I suppose. And then, so Baldy Catz, I don't know, he hasn't done anything recently, but it just these people produce nothing really as content. If you watch some of these Simon Dan videos, they're just nothing. It's just, who cares? I mean, yes, you're arguing something that a fucking 5-year-old could probably figure out, and the content isn't in any way interesting. It's not, it's not even Barney the Dinosaur funny. So I mean, it's just, you can't glean much out of it, and it is amazing that he has all these people throwing money at him, like he's doing humanity some great service, like somehow, this is meaningful stuff, when it has just nothing to do with the conversation that should be taking place, which is, what evidence do we have for any of this crap that people believe on this planet? And all of them need to be attacked, not just the flat earthers, but all the different idiots who are out there saying they know something when they really don't know anything. When they, like I said, physicists citing detector experiments that can't theoretically even take place, and yet they'll talk about them as if they happened. I mean, this is the kind of shit that just shouldn't happen. It shouldn't be possible for people to be duped. And it should be understood that the people who are being duped have this silly notion that they know something. So the worst part of the Simon Dan kind of audience is they all think they know something now, and they really don't know shit. They really haven't done any of spent nearly enough. They've spent way too much time watching fail videos and way too little time watching physics lectures and seeing the obvious flaws in them. Alright, so we'll do some comments, and then we'll go to Professor Lewin and just completely annihilate Mindless Marbles as any kind of reasonable commentator. I mean, he's obviously just become a troll now, because he's saying shit that's just so obviously wrong. It was, and then that idiot Stephen Bro, I pointed out how he deleted all his videos, so he put them back up. He unprivated them, I guess. So that's fine. But he made a new video on a completely different subject. So this is exactly why he was so useless, is that he's so distractible. I mean, you try to point him in a direction, and he just wanders. And here he makes assertions about the double slit experiment, and then he switches over to charge and magnetism. So I haven't even watched his little crap video that he's made. It's obviously something I said 2 or 3 years ago. I'm living in my other house, all that. And but it's probably just going to be semantics, because that's all he has, is superficial arguments. I point right to the videos I want you to debunk. I have them in playlists, okay? The subject videos. Debunk those, okay? Don't waste your time. And again, I have to keep pointing out, the channel's called Draft Science. And I've spent the 10 years that I've been making these videos, or whatever it is, just going through the process of fitting the pieces together. And at some period or some point, I might have said something that's bullshit. I would say, whoops, I made a mistake there. So what? I mean, it really doesn't have anything point to get to the parts where I'm really asserting something. There's parts where I'm thinking, and I'm doing it out loud in the video, and there's clearly parts where I'm saying this is pretty certain. Okay, so it's not that hard to figure out which ones are which, and they just play this stupid game. I got you bullshit on stuff, again, on a channel called Draft Physics, and they can't figure out that some parts are more draft than others. Ugh, just too stupid. Alright, comments. Miles Mathis is an idiot. Well, whatever he is, he's not an idiot, but he's obviously a sort of sociopath in the sense that he's claiming all kinds of conspiracies that just don't make any sense, and it's just a waste of time. And why bother doing all that crap? Why bother with a silly conspiracy theory? So whatever. It's not much of a comment, frankly. Alright, you can point out Dorothy Stratton faked her death to escape 15 minutes. I mean, I'm just saying that there's lots of outrageous claims. Again, you can't get much more outrageous than to have this silly theory that Stephen Hawking died 15 years ago, and for some reason, some conspiracy of people went across the earth trying to find another man with ALS that looks just like him to replace him with. I mean, it's just so fucking stupid that why would you even, why? It's hard to imagine a smart person doing that, right? So for that reason, you have to call him an idiot. But he's not stupid, so it just doesn't make any sense. He's psychotic. He's fucked in the head to think there's any point in this horse shit. Alright. Someone in this video would have been diagnosed with Asperger's back when it was in the DSM. What's in the DSM? Who cares? And what the fuck? I'm just saying that it is as a description of a disorder kind of silly. I don't like, broccoli. Oh, you have Asperger's. I mean, it's just too silly. It's a I don't like disorder. Yeah, okay. So I think we all have Asperger's, but I think there's a lot of stuff all of us don't like. But beyond that, it just doesn't make much sense as a diagnosed disease or condition of the mind. It clearly seems more meme-based and ideology-based and perspective-based than any kind of brain disorder. Okay, it's a disorder of, I like playing video games. I like reading comic books. I mean, that's the disorder, essentially. Okay, the fact is he also an asshole. Yeah, I've said it myself. Guess what? You're an asshole too. We're all assholes. We're all Pepper-style assholes. Just the fact of being human. You can't evade it, okay? Because we're selfish and we're all damaged by our maturation. None of us none of us grow up in any kind of environment that has any kind of rational structure. And so we're all damaged by it. Okay, as you are in the Oxford Dictionary under C for cunt. Yeah, well, asshole for certain, but yes. I mean, even this. And yes, it is a fact, because this is what trolls do with screen names. Oh, too pathetic. Alright. I've said some time ago under some comment section that at least mathematics have some kind of mathematicians have some sort of OCD, but knowing that Mindless Marbles is a math student, I mean, frankly, do we know anything? It's hard for me to take that seriously in the sense of what he's arguing is just so stupid. I mean, it's 2 + 2 and he can't get that right. And what the fuck can he know about math? I'll take it back. If he were anywhere honest, he would at least acknowledge that evidence for Einstein's relativity is weak. He acknowledged that evidence for wave theory is weak. The quantum mechanics evidence for entanglement and all this stuff is weak. All of their wooey assertions, all of the assertions that are, what the hell you talking about, wave functions and all this probability wave, all of this bullshit is weak. Every one of their particles, besides electrons and protons, the evidence is insanely weak. These aren't, they don't have great photographs. All of it's weak. Both theories suck. They just absolutely suck. They not only don't explain anything, they always assign a magic player, right? The magical bender of the space, the magical virtual photon, that causes pull. I mean, it's so stupid. And you can only know it's stupid from hindsight. I mean, you can only know it's stupid by knowing how simple the truth could be. And then you can look back and say, wow, that is just so fucking loopy as an explanation. Other explanations possible, they have two contradictory theories in a mainstream anyway. Well, yes, and the big contradiction is like one of them says everything's wooey, and the other one says it can't be wooey because it's making gravity every millisecond. So it can't be anywhere, it has to be somewhere because it's making gravity somewhere. It's not making gravity everywhere, so how can a particle be superimposed in all these different positions and at the same time being making gravity in a specific place, right? That's not really possible, is it? I mean, it can't make gravity in all these different locations at the same time. Alright, or no Eddington experiment repeated. Gravitational lensing. Stuff looks so weird it should be symmetrical. Why don't we see weird stuff in the sky? Yes, why, why is it not where it's supposed to be, and why is it where it is where it shouldn't be, and it isn't where it should be? Okay. Physics authorities saying contradictory stuff. Feynman particle, Walter Lewin waves, and not to mention simple experiments like double slit. Well, the point is, it's a dirt simple experiment, and look what they have done to it. Look how they have wooified something as simple as a double slit, and they pretend surfaces that electrons see solid surfaces. They've broken all of their physics. We're going to pretend we don't know what a surface is, that this chalk has a surface, right, to us, that's pretty straight and it's a straight line. Well, we know to an electron, that's not what it's seeing at all. It's seeing mostly empty space. That's the truth for the electron. How come they don't understand that? Or the photon. Photon traveling near a surface isn't seeing a fucking surface. Duh. There's not a steel wall, and the photon says, oh, there's a steel wall over there. No, there's no such wall. I mean, they can't even do that. I mean, they're so far, down the God, their religion, that they've lost all connection to their actual things that they're supposed to believe in. They forget they believe in those things and pretend they don't exist. All right. Feynman particles, Walter Lewin waves, and not to mention simple experiments, double slit, where looking at some brighter stuff through tiny connected fingers discredits randomness. Well, it certainly is ordered. I mean, how can it be random if we can force it to make exactly the same pattern over and over again? Okay, and like I said before, blah blah, I don't know what this link is to, just something pretty simplistic and not very useful. I mean, I'll go to it. I don't really know why he thinks this is of much value. 1, 2, and this is the little opening that they don't use with lasers. Lasers, you don't bother with this light spreader. But anyway, so I don't know how that proves something or demonstrates something, but whatever. Decreasing X or increasing the distance between 1, 2 makes light on-off pattern disappear. Doesn't make any sense. Well, that's like Walter Lewin talking about the hyperboloid or whatever he's talking about, the idea that the patterns are bending to get to the different locations. No, they're not. As you change the distance, you change what spots are light and dark. So if you want it to stay light, then you have to take a curved path because, well, where it'll show up light will always be moving. So you have to curve the path to meet where it's moving as you move the thing. But nothing travels that path. So it's bullshit. They're different photons you're seeing. When it's light over here, see, if it was light, it's light here when I'm a certain distance. And then the bright spot is over here when I'm a different distance. Those aren't the same photons. Alright, anyway. Increasing distance between 1 and 2 makes light on-off pattern disappear. Doesn't make any sense. In opposition to water that keeps expected properties. I don't know. Should I mention Heisenberg principle? Yeah, well, in the single slit experiment where there's a pattern before the principle is even applicable. A joke, not to mention overall observer woo. Well, clearly the observer part is just absolutely funny, almost. This whole idea of a measurement, and we only count the ones that we're aware of. But gravity's measuring everything all the time, and we'll just forget about that one. Okay. You are overall not better than people that got invested in some abstract model. Well, it's true, but I don't know. Pointing it out kind of sucks of you. That's right. I'm not special human. Yeah, just a variety. But it just happens to be the variety that works better. That works in some sense. You could implement it in some video game or to some point, but in reality it completely misses the point and doesn't match reality. So yeah, they can make up all kinds of Star Trek scenarios, and you can have tractor beams and all this little fun stuff, but it has nothing to do with reality. Double slit light experiment that is well mechanically explained by light scatter and bullets at frequency and consistent with other stuff. It's consistent with the idea of scattering parts and throwing them somewhere, and that the parts can rebuild what they start off being, especially if you have enough of them. Photons are more abundant than people realize. To see light, you have to have quite a few of them. Example, explanation consistent with photoelectric effects. Well, the photoelectric effect is, again, a dangerous standard for making arguments about particles and waves, because clearly the photoelectric effect is just basically saying tipping point versus no tip, right? I mean, I can hit something at a rate and it won't tip. I still applied a lot of energy and it's just not tipping. And it's only, I change the frequency a tiny bit so I get more energy pushing in one direction rather than fighting, the swing back. And so the more on resonance I get, the closer I get to it, there's some point where I will tip it. Okay, now I tipped it, so does that mean it was a clump of energy? No, it really wasn't. Alright, so fuck this. You really are such a douchebag for typing this crap. Well, that's obviously douchebaggily useless, but anyway. Why don't you join me on Discord? So the guy has an account that's 1 day old, and he's inviting somebody to go somewhere else to chat. I mean, what's the point? Look, I give you an open invitation. You want to show up into a Skype room, okay? And so if you want to do audio, you can do that. But I don't think you want to do that, because I'm going to force you to be somebody. Okay, and we can talk about the evidence for and against general relativity. We can talk about the fact that we all know what the evidence is, and it's not very impressive. You're claiming light is twice as bent by gravity. So the only force that's bent by gravity, and it's bent twice as much. Now, why would that be? There's no rational explanation. And the only experiment you have to defend it is the Eddington experiment, and all the other experiments can be explained as scatter. Because all the rest of them are inside the sun's corona. So you fail right there on that score. And then the fact that atomic decay slows down with velocity doesn't have to be connected to relativity at all. That just happens to be something that's true. So why don't you show us some other kind of clock, okay, being slowed down? So show us a different clock. Show us one that doesn't have anything to do with atomic decay, and show us that clock slowing down by Einstein's formula. Okay. You believe in a massive conspiracy theory. That's just a pile of horseshit. What, do I think religion is a massive conspiracy theory? It's right there in front of everybody. I mean, we're watching it happen. I mean, morons hear a silly story and go, oh yeah, that's really a great story. It's a silly fucking story. There's no, what's the conspiracy? What, you think the preachers got together and conspired to trick people? They don't need to. The people are right there to be tricked. They're doing it right in front of them. Again, there's no conspiracy required. I've pointed out how these idiots say things and they're just completely wrong, and then idiots like Mindless Marble show up and say, no, it's completely right. The distance doesn't have anything to do with point sources. Nuh-uh. When it obviously does, which I'll point out. I mean, it's just obvious right in front of you. I point out to you how there's no such thing as a fucking detector experiment. I pointed out how there's no way to make a two-slit experiment for an electron. First, it's so fucking tiny, right, that there's no fucking way to make anything called slits that are going to be appreciable by a fucking electron. There's just no fucking way to do it, all right, without having slits that are actually made out of like a half of an atom. You can't possibly confine an electron. Anyway, involving hundreds of thousands of scientists, engineers, etc., to hide the evidence against general relativity. The evidence against it is the poor quality of the evidence for it. So where have they hidden it? There's no hiding it. Again, you're the one who sits there and looks at the stupid smiley face in space, and you can see how there's no symmetry. You can see how lensing gravitation never does that. Gravitation doesn't have warpy little lines. The surface of the Earth is insanely flat, okay, considering the diameter of the Earth. The amount of irregularity on the surface of the Earth is minute, all right, when you consider the size of the Earth. And that's what gravitational things do. And the bigger the thing gets, the more gravity it's making, the more symmetrical and perfect the gravity gets. So none of these lensed images have any symmetry. They don't have any, they're not obeying any of those mathematical rules. Okay, so right away you can say, well, why are you believing it? Why are you jumping to the conclusion that the light was bent by this huge gravity that we can't see? We can't see the object. It's supposed to have all this gravity. I mean, I can make a simple argument to you. A galaxy has less density of mass than a sun. And a sun is less dense than an Earth. Again, I can tell you, the sun is 1,000,000 times bigger than the Earth, and yet the gravity is only 7 times greater. 7. 1,000,000 to 7. You can't figure out how, oh shit, yeah, you're getting this whole thing, you're misunderstanding how gravity works. I mean, so it's right and open. The silliness of the religion is right in front of you. The wacky, silly stories, the stupid Noah thing, all of it's so fucking silly, and it's right in front of people, and they sit there and say, I'm in. And all I'm saying is the same thing is taking place here. The evidence absolutely sucks. It's nothing like an argument between religion and evolution. There's no preponderance of the evidence just piling up and saying it must be. None of that took place. You're just pretending that somebody said it, that somebody somehow validated it, because you have little heroes, little nerdy heroes, and you believe them. You didn't do any of this. You didn't actually watch the experiment. You don't see, if you watch Professor Lewin, as I showed you, looking at the double, calling a pattern that isn't the double slit pattern the double slit. I mean, I'm showing you right in your front of your fucking face how he's looking at it, having these two patterns superimposed on each other. His math has no hope of answering it. He doesn't even put the width of the slits in the math, and you think, oh yeah, that's really good math. No, it's really bad math. And it's right in front of you. It's right in front of everyone. There's no conspiracy. You all just suck at logic. Okay. You have no idea about frequency analysis. Like that's a real thing. No, you have no idea about material analysis, understanding the difference between forces and matter. Anyway, and how that proves the distance of the galaxies in the lensing images. So again, frequency. What does frequency have anything to do with those lensed images? You are just so out of touch with reality, aren't you? I mean, really, lensed images, gravitationally lensed images from space don't have any fucking thing to do with frequency. Are about how GPS only works because of taking effects of GR into account. So it's more horse shit. It works because they're atomic clocks, and atomic atoms decay slower the faster they're moving. They already knew this from like muons, but they're not real, they're not real atoms decaying, so it's kind of a different kind of decay. So I shouldn't even mention it because it's really not the same kind of decay. They're not radioactive. But yes, radioactive isotopes will in fact decay slower if you give them velocity. Just a fact. That is, you move them about, jiggle them. Okay, because while they're moving, they're not going to be getting force equally from both sides of the universe, and therefore are less likely to have a decaying event. Anyway, go read the Wikipedia. So he types that in capital letters like, wow, go read what our ministers say. The ministers who wrote our Bible. Yeah, go read what they said. No, I've already heard what they say. They're idiots. What, you think Professor Lewin should write the Wikipedia page on the double slit experiment? Because clearly he doesn't believe in the envelope pattern. Clearly he doesn't believe it exists. Because he spent a whole half of a lecture talking about it and never even mentioned the envelope pattern. So clearly his description of it is going to be completely different than anything real. Okay, anyway. Wikipedia page on evidence for general relativity. Yes, I've already been over that. And I've already pointed out how that's all you have. The fact that isotopes decay slower with velocity, and the fact that let's say if I'm on Earth in acceleration, that I'm actually moving more distance because I'm moving up and down as I'm moving left and right. So obviously if I move up and down as I move left and right, I cover more distance. That means I have a higher velocity than it appears I have. Simple explanations, okay? And again, the gravitational lensing shit is obviously flawed. Can't repeat the Eddington experiment. We have bigger and better telescopes all over the place. We have big giant stationary ones, and there was a fucking 12 noon eclipse. I mean 12 noon, perfect eclipse, perfect weather. Nobody redid the experiment with a decent telescope. And you say that makes sense. No one's ever done it from space. We've had space technology for over 20 years. Nobody did it. What the fuck? There's no rational explanation for that, shithead. Alright, general relativity, and explain how all this stuff exists without a massive conspiracy involving thousands. So again, this massive conspiracy, no, it's just bad theory. It's illogical mush. It's a wooey religion, and that's all it is. They exaggerate preposterously. They cheat the truth all over. I mean, do you think Professor Lewin was doing anything other than cheating the truth when he described the two-slit experiment without showing the two-slit experiment? What else was he doing but being obviously neglecting facts? Okay, also go read accounts of physics in the 1800s. Why? Go re-look at the stupid Young experiment that keeps cited as some sort of miraculous experiment when it was so crudely done he didn't even see the real pattern. Okay, they wanted there to be a system similar to what Gary exposes. Well, that's a big fucking lie. They wanted exactly the opposite. The majority opinion was waves ever since the Newton-Huygens argument. And the fact is, the last real particle guy was Newton. So, fuck you, and that's insane fucking pretend fact you just made up. You show me somebody defending particles. Show me one person writing about it since Newton, other than Newton, who defended a particle theory. Show me, fuckhead. Any scientist, anyone would recognize their name. Show me one scientist who they would recognize his name who believed in that. And you can't even use Einstein, because clearly Einstein went for half of Einstein's whole philosophy was woo. Bent space is a woo theory. Why would they deliberately hide evidence? So again, another lie about some sort of hidden evidence. They're telling a fable and backing it up with superstition. There's nothing here. They're claiming invisible man and gremlins. You think the world is run by them, just like the religious kooks, explain that demons and angels are controlling events on Earth. Okay, it's horse shit, plain and simple. No evidence for it. No good reason to believe it. It's a crappy theory. It's stupid as a story, and it's badly evidenced. And that's really, that might as well be 3 strikes. I have a math degree. I doubt that highly. Because again, you can't make these assertions. You can't figure out that a distance is basically saying the distance between 2 points. And I'll show you Professor Lewin directly showing you by having 2 speakers at a distance. Okay, what do you think the speakers are if they're not point sources, retard? They're obviously point sources, retard. Oh, God, these people are so fucking stupid and dishonest. I have a math degree and can understand why Lego would never work right if Gary was correct. Well, again, if Gary is correct, it can't work. That's right. And so you think their mirror of 32 layers of film always reflects a photon from exactly the same location in time and space. That no photon goes too deep, no photon goes too shallow. They all reflect from exactly the same fucking point, 1,600 times in a row. You think that's theoretically possible. Then you're fucking dumb as shit. Then you'll buy almost anything. If you'll buy that, you'll buy almost anything, right? Because the laser would drift by entire feet. Drift where? If I was right, why would the laser drift, idiot? Why? The frequency would drift. Yeah. But it wouldn't drift side to side. My theory doesn't explain why a laser would not be a laser. You liar. So again, what the hell is that? It makes no sense. LIGO would never work right if Gary was correct, because the laser light would drift by entire feet. Where is that? Where? Drift where? Where does my theory require laser beams to drift? Oh, that's right, it doesn't. You'd be a lunatic to think the scientists don't notice or noticed, but choose to conspire to hide this. Again, they're not hiding anything. Well, they're hiding the details, so we don't get to see the real data and the real way they contrived what they're looking for. Clearly they're just creating a gigantic sea of data. So they're burning a whole bunch of pieces of toast, 1 billion pieces of toast. And then they just say, well, what are we looking for? Let's find all the toast that has an image that looks like Mary Poppins. And that's all they do. They go out into the 1 billion pieces of toast and say, any Mary Poppins here? Oh yeah, here's one. There's gravitational waves. It's that bullshit. And the fact that you fall for it and you're a dupe to it, it's like I said, what is there to say? You won't concede first. The evidence is very weak. That, obviously LIGO has a lot of moving parts, and it's pretty suspect that it can do what it actually says. And again, I can just point out that they've never tested the damn machine. They never sat there and just hung a weight over the tunnel and swung it back and forth. A nice big heavy lead ball. Just swing it back and forth over the tunnel that has the mirror in it, and see if they can detect the lead ball moving back and forth. What's so complicated? Why can't they do a test to show that they can measure these tiny changes in the gravitational field? All right. You just don't account for any of this. Again, it's a simple argument. The experiment would cost almost nothing to do with the current satellite technology we have. All we have to do is point it and take a few pictures. 1 day out of the satellite's life to validate Eddington. How come it can't be done? How come it hasn't been done? How come scientists haven't demanded that it be done? Yeah, so stupid. Alright, fuck this. I have sometimes some cognitive dissonance that is conspiratorial, but then I turn on my rational brain and I just think you're a bunch of idiots. It's still a joke that in 21st century I talk with people and they mention some BS they found DNA of Jesus here or there. Yeah, well, there's lots of claims, and what there isn't is much evidence for any of them. No wonder sometimes DS might seem he is full of himself when you give him such opportunity. Yes, there's every opportunity to say, man, I'm a miraculous human being that I somehow don't fall into all these silly nonsense traps. You know, I mean, I basically am walking on water compared to you drowning fuckers. Okay, I would be as well. At least he recognizes that from time to time, and regardless of what other people say, I think he is quite humble. Well, the fact is, yeah, I'm not saying I'm entitled and I'm special and all. I'm saying I still have to make the arguments. I don't get to just declare the truth. I have to defend the truth. I responded, but YouTube's algorithm thinks I need my freedom of speech infringed upon, partly, no doubt, because Gary deletes so many comments. Well, what would the two have anything to do with it? YouTube obviously did it for some reason, but you probably put some kind of stupid statement in it. But anyway, the algorithm takes that into account. Well, you're again proposing another theory. You really think that's what the algorithm does? I think that's kind of bizarre and silly. I don't think the algorithm changes based on my behavior one tiny bit, shithead. I don't think you have any evidence that it does, that you really could give a shit. I responded to everything you had to say. Oh, isn't that too bad that you lost it all? You don't even know how to save what you're typing, huh? This should be evidence to you that Gary doesn't have an argument. If you need to modify the feedback, it's because you can't handle it. Well, so this is just all a big, says you. I don't have any, like I said, I can show you, I don't have anything blocked. There's nothing that stops you from commenting. You can keep saying it, but it's a lie. I don't have any problem commenting on the internet. I can figure out how to do it. Alright. If you need to modify the feedback, it's because you can't handle it. Time to see my psychiatrists. Well, whatever. You got the last word. So, yeah, just a pile of crap, right? He didn't account for anything the guy said, blah, 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 blah. Alright, so Dino had made some comment about stupid neutrinos, and he says, but what about the neutrinos? You never got to the neutrinos. Wink. Yeah, okay. So this is some Miles Mathis crap. I don't know why people have to type in caps and do this kind of crap. Okay. Let's see. I think it's okay to unpin. Okay, we already did that. So where's Dave's stupid... Oh, sorry. Who is it? Who said it? Dino. Okay. So he's got some kind of comment here. Okay. Alright. Is it reasonable to compare the properties of force bits to those of neutrinos? You know how much I hate the whole idea of you bringing up neutrinos, right? You've got to know that these are the fakest of the fake particles, right? These are just mathematical. They have a mathematical problem, and like gravitational lensing or they'll just invent dark matter to fix it. Neutrinos are dark matter, okay, for the atomic structure. They're just some sort of made-up thing, okay, to say, yep, there's a made-up thing that does this. Now, there's no point in like saying something that can go through the earth, okay, without hitting anything is something we can detect. Well, that's horseshit. Okay. Yeah, there could be some comparison in the sense that obviously I'm pointing out how the strong force isn't the strong force, right? It's an incredibly weak force in the sense the electrons are just dissipating all the energy, so there's no force. You need to push the protons together. They slide together really quite easily once an electron's in place. So there's no strong force to account for. And these leftovers are based on saying how much speed does the particles have when they leave in an atomic reaction. And clearly we can't account for all of that energy because there's energy between the electrons and there's energy between the protons and the neutrons. I mean, all of them are capturing energy. So the fact that we don't see all the energy come out means that some of them are in forms we don't see. So just like the photon argument, I'm clearly arguing that if you put photons through a double slit experiment, for example, not as many photons get through the experiment that went in. So less light than what went into the slits ends up going to the target. So photons are destroyed in the process. Now, the destruction of the photons doesn't mean the energy is destroyed. It just means that they don't see them as photons anymore. So clearly in an atomic reaction, you could understand that, yes, some of the energy leaves as photons that we can see. Some of the energy leaves as photons we don't see, as pieces of a photon. And yes, that could be called a neutrino, but I think that would be just playing games, right? There's no massless particles in the universe. There's no massless anything. To have momentum, you have to have mass. And the only thing that could possibly matter in the universe are things with momentum. So if they don't have any momentum, they can't possibly be relevant. So their arguments are just silly, okay? Massless particles is a silly notion, can't mean anything. I'm not suggesting that they are the same thing. Well, you sort of are, but, whatever. But the way that they each describe, they seem to share some similar behavior. I don't know how it could all be at all similar when you have, electron neutrinos and tau neutrinos and blah, 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 and all this horse shit. I mean, it's just horse shit. I don't see any point in trying to fix their model by rationalizing it into something more sensible. There's force all around us all the time. And some of it's in a form we can detect with our instruments, and some of it isn't. That's it. That's all you need to know. Do you think there's anything in neutrino research? Absolutely nothing. You can't research something that goes through the Earth without being affected. You're not going to research that. That could help support the idea of gravity as a push force. Like I said, there's leftovers in all kinds of places that could end up supporting the idea of the push force. I mean, just again, recognizing the difference between the energy of a photon and a photon. So I'm arguing clearly that when you see the double slit pattern, there's no energy going to the dark spots. There's plenty of energy hitting the dark spots, the same amount of energy that's hitting the light spots. It's just in a different form. And even them figuring that part out could be an asset to them understanding it's a push universe. That's an intriguing idea. The very idea that we only measure a certain, the microwave background radiation, that this radiation of the energy in space, it took us a long time to even know it existed, because we can't just detect energy. We have to detect it in a form. We have to watch it move a piece of matter. And matter only moves by certain rules, and sometimes it doesn't move by the rules. Like I said, if we were using the photoelectric effect as a way of seeing energy, you could understand that, we'd only see blue light then, right? We'd never see red light. It'd be invisible. Well, they say now that if you hit it with enough red light, you might get a little bit of a response. So sometimes the red light can mimic a blue photon. When I studied physics, they treated neutrinos as these abstract objects that kind of set properties, but they never really tried to go out and find their effects in the real world. Again, you can't find their effects in the atom. You can't find their effects anywhere. All of these particles they've invented, besides electrons and protons, can't do anything. They don't have any function. There's no way to describe what use they are in an atom. One of the many reasons I chose to leave academia. Well, I don't know if that's true either. I thought I blocked this guy. I thought I did. So, well, whatever. I guess I didn't. Well, we'll see. We'll see what he does. Because I think it's a fake, a phony, and an asshole. Oh, yeah, that's before. Yeah, I blocked. That's a comment to the old Dino. Yeah, so he is blocked. Yeah, I don't believe you did anything. I left academia. Yeah, sure you did. You became a ditch digger. Okay. So, I guess we've covered it all now. Alright, so on to Professor Lewin video. Taking up where we left off. Now this part's really kind of important, but I'll preface it with what I have pointed out clearly as the explanation. Whoa, I didn't see that happening. Stay focused, camera. There's a project here we're working on. You can't just do what you want to do. You know, you gotta get with the program. Gotta do your part. You know, don't be an asshole. Okay, that should be good enough. All right. So as I pointed out, the whole two-slit thing is, and this goes for the end slits. Okay, the whole mathematical circumstance, and this is true for their own math, right? So their own math uses this distance in analyzing this single slit. And if I use the single impediment experiment, it's obviously this distance, which can be the same distance. And all it is, okay, there's no mystery. This isn't about photons going through or photons being blocked. It's just about a location. This is what's in the math, okay? Now they're saying two waves interfere with each other. Now, the two waves would have to be in here somewhere, right? I mean, obviously a wave is not going to be made here, and a wave isn't going to be made here. That has no logic. It doesn't happen with water. It's not going to happen that way. But this is the actual distance. And what's it a representation of? It's just a representation of the fact that if I take an arbitrary distance from the source, okay, and I make the same distance here from a center point, right, that you could just see that this line is this long and this line is this long between those 2 points, and the difference is this. And all you're really going to say is what's this distance spread over this arc, right? Because that's the entire experiment. 90 degrees and you're done. All done. It's all over. So it starts here at 0 and it goes to its maximum at 90 degrees, and that's it. The whole experiment is done in that arc. And all you're doing is taking these wavelength differences and spreading them over this bigger line. So this line, right, this arc over here, is 1/2 of a pi, okay? 1/2 pi is this arc. This half altogether would be a single pi. So you're just saying it's this radius times 1/2 of a pi, or the whole diameter, but we're not doing the diameter. So I'm just saying that's it. So the increase in the distance is 1.5 or 1.6. Okay, so this line is 1.6 times longer than this line. That's all it's saying. So the difference in this distance, I gotta make sure, yeah, I didn't just compromise. Obviously you're counting the less distance this way and more distance this way. So I'm just saying that's the only thing that's a complication. So you're just saying that the length of this line from the center point, okay, and proportional to the length of this line. And so now you're just saying what's a wavelength difference proportional to this difference. So anyway, the point is that all you're really saying is that you're going to have a certain amount of wavelength differences, and those will be put over this path, this longer line. So you're just dividing the wavelength into the longer line is what I'm basically saying, right? So this line is this long, and if I have the arc line, I know that line is this long. So if I straighten this line, this distance, it's just a longer line. And so now I can just say it's the same number of notches in a longer line. So if there's 10 notches here, there's 10 notches here, and they'll tell you exactly how big each one of these ons will be. So you'll know exactly what size they are. And that's all that's in the experiment. There's nothing else in it. So clearly, the point sources are here and here, the surfaces, and clearly all you're saying is if I scattered pieces to all these locations, there's places where the pieces are still in phase. That is, from here and here, they're both in phase. They're one wavelength difference, or two wavelengths different, or three wavelengths, whole wavelengths different. And those are all these points. So if I scattered the bits, if I broke the photon into billions of little pieces, and I just throw the pieces at the wall, There's places where the pieces can't be in phase, and there's places where the pieces can be in phase. And so you make a photon, you break a photon. You make a photon, you break a photon. But there's no constructive interference. There's just constructive reconstruction. You remake the photon, you remake the pattern, right? You break all these pieces and shoot them into different directions. Well, the direction is they're all going to hit the surface. And the idea is that sometimes you have pieces that were in the same phase, you put them back in the same location, and there you go, you got a pattern again. So you're just remaking the photons. It's that simple. There's nothing to this. Alright, so now I'll just show how Professor Lewin, and so when Professor Lewin did the single slit, he did it as if it was, the double slit, he did it as if it was a single slit. It only had 2 point sources. He did the math with just 2 point sources. He didn't consider that these two are also players in the game. And the clear fact is if you consider it with all 4 of them, you can make the double slit pattern. That is, you can make the envelope pattern with these two, with this distance. That tells you how many of these there's going to be. And this distance will tell you how many of these little bars there's going to be inside. And all you're doing is putting those 2 patterns on top of each other. And obviously the little bar pattern has these 2 notches in it. But those 2 notches are on top of nothing. And so they're not bright enough to make photons. So there's no photons. The only place you can get a photon is there has to be 4. The 4 point sources have to be in phase. 4, 4, 4. You see the place where the 4 are in phase. You can't see where only 2 are in phase. That is, the bars are here, but they're not there. Or, where you only have a contribution from 1. Now, obviously, the small pattern is on top of the big pattern, so obviously there's no place where the big pattern is, and there's no little pattern, because the little pattern is much smaller, so there's always little pattern. But the truth is you need 4. You need 4 point sources in phase to see the photon. 2, not enough energy. 2, not enough energy. You need all 4 of them to be in phase, period. And that explains the experiment. So the inside diameter makes the big pattern, the big blobs, because there's very few wavelengths. The distance between the 2 outside surfaces makes all the little bars, and it completely explains the experiment. No waves necessary, no waves even possible, right? The wave would be here, the wave would be here, the wave would be here, the wave would be here. It doesn't make any sense. It's half over the surfaces. Why would the wave be half over its surface? The center of the wave. Can't work, won't work, doesn't work. Professor Lewin did it by saying the wave centers are here. Okay, that was the distance he used. Alright, clearly that won't give you the right answer. It won't. He didn't show it giving the right answer, he just says, close enough. I predict it's 3.7 centimeters apart. Did he go to the board and measure 3.7 centimeters? No. So, completely unproven, undemonstrated that 2 waves in these locations, in his locations, which are here and here, okay, can possibly create that pattern. Point source here will not mathematically work. The point sources have to be here, have to be here, have to be here, have to be here to get the correct answer. Now obviously you make these slits small enough, the difference between this and this will be so slight that you won't be able to tell. But obviously with any regular experiment you're going to see this huge difference between this and this. That one of them's going to have 500 bars, the other one's going to have 300 bars. So obviously 300 notches is going to be in different places than 500 notches, and the difference will be different. Okay, but his math was egregious. This wasn't in the frickin' math. How can you take this out of the math? Okay, how can you take this and this out of the math and pretend it's the double slit experiment? This is the single slit experiment. This isn't the double slit experiment. No point here, no point here. No hope of being the right experiment. This is the single impediment experiment. He did the math for the single impediment experiment. He didn't do the math for the single slit. And again, he did it wrong because he put the waves here and here. Okay, technically. Well, no, he didn't technically. You can even understand that, right? When they're doing the single slit, where do they put the waves? where does the math, when they do the single slit math, where do they put the waves, right? So I have a single slit. Where do they put the two waves? They put them here and here. They don't put them in here, okay? There's not two waves in here. Their math clearly says this is the point source center, and this is the point source center. The D in their math is this total D. The D isn't a wave here and a wave here, because that won't give the right answer. So again, just understand, how does that mechanically fit? How does, you know, water waves don't do that. So why the pretending? Water waves don't do it at all, in the sense that water waves in the single slit just do this. They don't create any interference pattern. The fraud is obvious. The deception is obvious. The playing with the evidence and presenting it to you in a fake and phony and fraudulent manner is obvious.
You can do with light, if you can turn light plus light into darkness, then obviously you should also be...
So obviously the point is it's not light plus light. It's two pieces out of phase. So out of phase pieces and out of phase pieces, yeah, won't equal in phase pieces. So if the pieces are out of phase, you're not going to reconstruct a viable photon. They have to be in phase, or you're not going to have the frequency.
Able to turn sound plus sound into silence.
So there's no such thing as sound plus sound into silence. There's not light plus light equals no light. Okay, it's just pieces are either in phase or not. You break it and then you remake it in some places. That's all there is.
It's a matter of scaling up the whole experiment. And that is what we have set up for you here. We have two loudspeakers. So all the equations that you have here apply.
So again, this is the double slit equation, which is really just the single impediment equation, right? It doesn't have the external surfaces in the math. So he first did the double slit by just doing the single impediment math. And now he's going to use the single impediment math to describe 2 point sources of speakers. So just understand, okay, he's using the same math.
Verbatim, except that we scale it a little bit. So our D is no longer a quarter millimeter, but our D is now 1.5 meters. So here is a source of sound.
So he's just saying 1.5 meters is now the D, the variable. So he's pretending there's two light sources that are that far apart, and then he's going to have a very high, lower frequency, which makes that distance mean less, which is obvious. Obviously, if you use light frequencies, this wouldn't mean anything. But clearly, the D is going to be the distance from the center of this speaker to the center of the speaker. That's the D. All right, so there's no doubt about it. There's not two waves coming out of something. There's not two blah, blah. No, there's 2 point sources.
And here is a source of sound. And they are fed by the same electronics. And so the D, the separation, is 1.5 meters. And the frequency is 3,000 hertz. So we do this experiment.
So the frequency is 3,000 hertz, which you got to convert that into wavelengths. So that's I don't even know why he bothered with that, but yes, you got to put that into a distance, and then you're just going to divide the distance, the number of frequencies, in phase, out of phase. You're just going to divide the wavelength into the distance. That'll tell you how many possible nodes you have. Just like with the light experiment.
For sound. And so lambda is about 11.3 centimeters if you take...
There you go. So he's just converted 3,000 hertz into actual wavelength distance, and so it's 11.3 centimeters. And so now he's just going to divide 11 centimeters into D. Now first he's going to do it the hard way, but I'll go ahead and show that it's an unnecessary step.
340 meters per second for the speed of sound. So we have in a way monochromatic light, monochromatic sound, more or less one wavelength. And so you can calculate what lambda divided by D is.
Right, so dividing D into lambda is doing a percentage. Okay, so what he's really doing by doing that is saying what percent of 100 is it? And so he's going to come up with a decimal point, because the D is bigger than the wavelength. and it's just going to give him a percentage of 10 would be 1. So 1 would be, that would be, you just convert it into a percentage. So you're just converting it into a decimal point, which means you're just putting it into tens. Okay, so, well, anyway, let him finish doing that. But it's unnecessary, because the only one you need to do is the lambda into the distance. All you need to know is how many wavelengths fit inside the distance between the two speakers, and that'll tell you exactly how many places there can be constructive reconstruction or constructive interference. Again, where are these waves interfering? See, this sound is in a physical medium. It moves both ways, first of all, right? It adds pressure to the atmosphere, it takes pressure away from the atmosphere, okay? But it still comes out as little rays. I mean, the atoms are being pushed as individual atoms. They're not doing something collectively. They're moving as individual atoms. So you can draw it as waves, wave, 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 or you could just draw it as rays. Same difference.
0.075. And so you can calculate where now those surfaces are. They are really hyperboloidal surfaces. They're coming out from the center here, and they bend.
So you're really just saying how many times does 75 go into 100, and that'll tell you, or 1,000, how many nodes there'll be. So 75 into 1, 0.075 into 1, and that'll tell you that, 13 times.
In your direction, where all those hyperboloidal surfaces are, where there is no sound, and then you can calculate where all those hyperboloidal surfaces are, where there is sound. Let's first calculate.
So there's no hyperboloidal surfaces. So let's just, I'll just draw this real quick. That there's no point in talking about there being any curved lines here. There's no curved lines. So they're just, again, that just makes it seem like it's weird, to talk about hyperboloidal surfaces. Okay, so the point is you have 2 point sources. That's all it's really about. And you have 2 vectors. Those vectors are always straight lines. Now, obviously, if I move this target out, okay, the place where these two intersect is always changing, right? So when I go to a new location, if I go this distance or I go this distance, these are 2 different lines, right? Okay, so on and off will be changing constantly. So if I was to say, what's the proportion, the effect, as I go wider and wider, what am I really doing? I'm just making the blocks bigger and bigger as I go further and further out, right? So all this is doing is saying I'm just magnifying how big. So a square this size here ends up being a square, much bigger over here. Okay, and if I was to measure where the on part is, the on parts will take a curved path. But that's not what this thing is doing, okay? It's not measuring where the ons are. It's measuring 2 straight lines from the 2 point sources. And the fact is that for it to be in phase, the in phase part will change by a different distance as I get closer. The distance from out of phase is this, and then the distance close here is this little tiny distance. This distance is changing. That's the bend in the line, is just the fact that you're stretching the distance. Okay, but nothing travels the curved path. Nothing. It doesn't exist as anything. Nothing travels a curved path. It's just a consequence of magnifying the image by projecting it to a greater distance.
How many hyperboloidal surfaces there are. So in order to do that, we simply have to stick in our equation, d sine theta equals n lambda. We just put in theta is the maximum value possible, and that is 90 degrees. So you put in theta max.
So here you go, right? Why didn't he do this for the 2-slit experiment? He just told you we know what n is now. We know how many n's there are. There's a limited number. He just pointed it out to you. So he did exactly what I did in pointing out, look, this is just an arc. That's it. You go from the maximum here, you go to the minimum here. The difference in the line. Difference in the distance to the target. Okay, so, and there's just the same number of wavelengths there are as the same number that you're going to project on the screen. So the further apart they are in number of wavelengths will tell you exactly how many nodes there are. There's exactly as many nodes as there are number of wavelengths in the original distance. The distance defines the nodes.
and that is 90 degrees, 5 over 2 radians. And so when you do that, you'll find that n max, that is the highest number of n in that series 0, 1, 2, 3, 4, 5, that n max is then d divided by lambda.
What the hell happened to the sound here? Okay, so we just did what I said. D divided by lambda. So you're just dividing the wavelength into the distance, and it'll tell you exactly how many nodes there are.
Which in our case is about 13.
13, there. Which is the same as doing the percentage of 100. And you'll get the same answer, 13. So you can do it more than one way. So this is the trick of math. So he's doing this math as complex math, when all he's saying really, okay, I mean, let's just be clear, all he's saying is, this is the arc that I'm projecting it on, right? And this is the distance I started with. And all he's saying is whatever you can put in here, you're going to put the same thing on here. And that's all there is. There's nothing else to this. There's a line, a line, a line, a line, a line, a line for each of the wavelength differences. And that's your total number of nodes. And the total number obviously are fitting proportionally, symmetrically across that whole distance. So you want to know how big one of them is? You just find out, you just divide the 13, okay, into this distance, and it'll tell you exactly how many inches you can expect it to be at this distance. The distance that's consistent, this distance of your radius is a consistent number. That's it. Completely explainable by scatter. And scatter explains why the pattern runs out. That it doesn't really go all these places because the photons don't scatter this much. Yeah.
It is 1 over this number. So
yeah, 1 over this number, exactly. So you got the same answer 2 different ways for no real good reason.
Means there are 13 of those surfaces going in this direction, but there are also 13 going in this direction. Remember, we have plus and minus. So you really have to multiply this by 2.
Right. So you've heard me say that a few dozen times by now. That obviously, if you're going to count the number of nodes for the whole 180 degrees, you have to multiply the number of wavelengths by 2.
So there are 26 surfaces, no more and probably no less, in this audience of constructive interference.
Now, if they said this, right, the double slit would be debunked. So if they did this with the light experiment, everybody would see this arc and everybody would understand what's really happening is that you just have places where the light goes and it is, you know, in phase, and places where it goes where it's out of phase, and there's a limited number, and there's no magic anymore. It ceases to be mysterious.
And then there are probably also around 26 destructive interference.
And it clearly would also show that the wave is in the wrong place. That clearly in his diagram, the distance, okay, if these were 2 point sources of light, obviously the distance wouldn't be the distance of the, you know, between the edges of the speaker. No, it'd be to the middle of the speaker. That's where the waves are. So the distance would have to mean that your wave is on top of, overlapping the surface. That half your wave is somehow over the slit, which you know wouldn't happen. Certainly doesn't happen with water. So you know that the point sources, the wave sources in the Young drawing can't be right. It can't create the right pattern because the point sources are in the wrong location. The center of the slit, the distance from this one center to the other center, won't give you the right answer.
So now I want to be as quantitative as I can be, and I would like to know, the students who are sitting about 5 meters away from me, what the distance is between one maximum, the 0 order maximum right at the center, and the next maximum. We get an idea where to search for those maxima and where for those minima.
So now he's just saying I'll establish a distance, that is how far away my radius is going to be, and the longer I make the radius, obviously the bigger the length of the curved line, the arc, and I'm just going to put the same number, 13, into the bigger curved line. So if I make a little arc like this, okay, then I put 13 into that little distance. I make a big arc like this, then I put 13 into that big distance. And so, but that's it. It's just nothing There's absolutely nothing interesting once you dissect this thing. There's nothing that says waves, and everything about it says scatter. Everything about it says the point sources are exactly where you would expect photons to scatter. They hit next to a material surface. The material surface has electrons all over it. The photons are obviously hitting the electrons. They're obviously being scattered by that process, and by being scattered, they're breaking essentially, and now you have to reconstruct them.
So I will go now for the maxima.
Particle theory wins big time. It makes so much more sense. It fits the evidence so much better. It's mathematically sensible. It works. Absolutely no reason to create waves in silly locations to contrive that it works when it doesn't. Again, their single slit math says the 2 point sources are where the surfaces are. Why would the wave go over the surface?
So I know that at theta 0, right here, all of you here sitting here must hear a maximum there in this plane. Now,
Yes, because the two lines are exactly the same length. So yes, that's how it has to work.
the question is, where is the next maximum? Well, the next maxima depends, of course, on the distance, how far you are sitting away from me. So I take the students which are about 5 meters away from me. The sine of theta 1,
You just take the distance, okay, which is a radius, okay, and you multiply it times 1/2 pi.
this 1 now makes reference to n equals 1, that is the first surface away from the center. So the sine of theta 1 is then 0.075. And that translates into a value of theta 1. I think it's about 4.3 degrees, that's right.
So he's doing it the hard way, in my opinion, right? Let's first turn it into an angle, and then turn the degrees, and then turn that into centimeters. When the easy thing to do is just to convert it directly into centimeters and just say, how much bigger is the arc? The arc is 1/2 pi bigger, so just multiply the wavelength times 1/2 pi bigger, and you've finished your job. I mean, 1/2 pi times the radius, the distance. Done.
And so now you can calculate what the separation is between one maximum and the next maximum. That separation x1, I call it x1.
So this tells you the node size. Obviously, the node size would be the size of an on and the size of an off. So you have to make that bigger. Okay, double that to get to the actual size, the actual distance between the centers of the nodes.
Is roughly L times that 0.075, and that is about 38 centimeters. So right there, those guys that I'm looking at now, you will have a maximum sound here, and when you move 38 centimeters, you will have another maximum, and there is a minimum in between. So the minima and the maxima right there, where Eliseo is sitting, is about 90.
Right, so the distance would be 1/2 that would be the distance between a maxima and a minima. And that's what you need to know, because that's going to tell you on versus off. So the distance between on and off are, you can hear it because the sound is constructive. You can't hear it because the sound isn't, one speaker is going in while the other speaker is going out, right? Kind of obvious in wave theory. And obviously sound is a wave in the sense that sound is moving molecules that can go in two directions. There's no indication that photons can pull. They can't pull on atoms and make something move towards them. They can't make your eardrum go out. They can only make your eardrum go in.
Centimeters. Now for you there in the back it is larger, and for you here in front it is smaller. Because remember, those surfaces go like this, and so here the separation is smaller. I'll just give you this as an example, that you know roughly an order of magnitude of what you...
But just understand, why would he throw this sound experiment in the middle of the sequence of doing the light experiments, except to make some kind of argument that there's an ether? I mean, they're just ether theorists, okay? They all believe in ether. They believe there's some medium, electric field, some medium, okay, that can be moved forward and backward. Even though there's absolutely no evidence of ever, okay, a piece of light creating backward movement.
You are looking for. Well, I'm going to turn on the sound now, and then I want you to wiggle back and forth, as you did when you were nursing.
Alright, I'm going to skip this a little bit because it's an obnoxious sound, and then he's going to explain how they're all dummies because obviously 13 centimeters or whatever it is, 16 centimeters is really the distance between your eyes and your ears, and you're not going to be able to hear it, and I should turn one ear to it and block the other ear. You won't be able to detect the difference. So you have to block one of your ears, and you probably have to turn your ear towards the speakers, blah, 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 blah. So we'll skip that nonsense.
Dividing lines between A, B, C, D's, and F's.
Okay, then there's grades. Well, let me...
I owe you something.
Well, fuck that.
Hi, I'm Melissa, aka
Oh,
Girl Mama.
fuck
Check
that.
out the Virtual Smokehouse store on Kingsford or Masterbuild's YouTube page.
Yeah, fuck that.
A more comfortable fit that protects and flexes with you.
Fuck that.
And the only thing stronger than us is you.
It's hard to believe that he really needs this money. You know, his excuse is he sold his video collection to an advertising company. Okay, you know, and so they gave him a bulk amount of money at one time, and he sold out for that bulk of money and gave them some sort of, I don't know, I wonder if the rights are forever, you know, so they can be putting ads on his videos forever. Ugh, pretty disgusting thing to do. I mean, he's a professional physicist. You know, for a few $1,000 he's sold out. It's pretty tacky.
Oh, if someone is going to help me.
Okay, so I guess it's too long a video to cut into pieces.
All right, this is the great moment for the mini break, the mini quiz. So if someone is going to help me.
All right, so nothing really happened. Everybody's, oh yeah, I heard it, or I didn't hear it, you know. Okay, so, but that was it. All right, so we're done with mini quizzes.
So now I will continue the idea of interference, which has very far-reaching consequences, and I will turn to what.
All right, let's understand. There's just no interference in any circumstance. All you're really doing is saying, can the two things they never interfere with each other, except when you're doing it through a medium. I mean, obviously, if I push in a medium, you know, a Jello, I push this way from one hand and I pull on the other one. So I'm pushing with one and I'm pulling with the other one. Obviously, those two things, where the Jello is moving in and the Jello is moving out, when they intersect, they're going to be nothing. But there's no reason to think light does anything like that.
Called thin film interference. And I will cover normal incidents. It really doesn't change very much if you change to a different angle.
It does change a lot. So he said it doesn't change much based on the the incidence of the light, but of course it does. So we're just talking about light coming straight in and straight back, and that's when all of these index numbers have a standard number. But obviously if I change the angle that the light hits the surface, a lot more of the light reflects, a lot less of the light transmits, so blah 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 blah.
So it is the same. Thin film. I have here a thin film of oil, and we will shortly see what I mean by thin. So this is air, so we have plane waves of light coming in this way, so it's normal incidence. And this is N1, which is air, so that's about 1. And this is N2, which for oil is about 1.45. Let's make it 1.5, just so we round it off. And this is N3, which is again air in this case, so let's make it 1. It doesn't have to be air, but I will make it air. And let the separation, or the thickness, I should say, of the oil be D. And I call this surface A, and this surface between oil and air, I'll call that B.
Okay, I don't know how this is all that interesting. We've sort of been over this before, but again, it's the same idea. You're gonna have some portion of the photons, the bits, are gonna bounce off the surface. They're gonna hit electrons and get fucked up, and that'll be 4%. And then the light's gonna keep going through, and it's gonna hit the other surface, and the same shit's gonna happen. So you're sending bits, scattering light off the surface, and then you're going to scatter light off this surface, and again you're just going to combine the light back together again with some detector up here, and it's going to see pieces coming from the one side and pieces coming from the other, and the only time it can make a photon is when this distance all the way down here and all the way back up again is the same as the distance of a wavelength. Now the catch is they use this stupid refractive index, and really they do that to convert the frequency. They pretend that the light changes frequency as it's going through the material. you can just as easily point out that the distance isn't actually the right distance, okay? That when the light is actually being transmitted, it doesn't travel a straight line. The light jiggles a little, okay? So all it does is travel a little extra distance. It never changed its frequency. It's just the distance it traveled was a little bit longer. So obviously you could have a full wavelength difference with the material closer together because the light didn't travel a perfect straight line in either one of those directions, up or down and back up again. And so this is another place where the math can be, you can rederive the equation in a completely different way, just understanding that the frequency never changes, the distance changes, because the light doesn't travel straight lines through the transmitting material. The transmitting material obligates the light to travel less than a straight line. The force.
So that light come in, normal incident.
And that's just one way. You can also just figure that if it hits electrons and the electrons move slower, that the light actually does lose speed. Okay, so it's just another way of understanding it. If the light has to move electrons, the electrons move slower than the speed of light, therefore the light got slowed down, and it'll give you the same problem where you just have to say for it to be in phase, you have to compensate for the fact that it got slowed down by 40%. So I'm just saying there's completely different ways to interpret the mechanical mechanism that's changing the variable. But the thing to understand is the only thing that's changing is that obviously if you change the speed of the light or you change the distance the light has to travel, that those are going to change how the wavelength number, and that the distance won't be a full wavelength. You can't just measure the distance with a ruler and say that's the distance the light traveled or that's the speed the light traveled. You have to either account for the fact that it traveled more distance or it traveled slower. That's what I want to say.
Comes in from above, over a large surface. I just put in one arrow here, and let that intensity be I0. And now I'm going to calculate how much is reflected back into the air. And I put the arrow here, so I offset it, just for the purpose of clarity. So some of it is reflected, and some of it goes straight through.
Now, they never prove any of this stuff, right? So they never prove that 4% comes back up and none of that light is broken permanently. So they don't give you any idea of that. So when he says 4% goes up and 96% goes down, maybe it's not 96%.
And all of you are more than capable of calculating how much is reflected. At that point A, the R, the reflectivity of the E vector, is N1 minus N2 divided by N1 plus N2, and that is minus 0.2. The minus sign tells you that there is a flip here in the E vector by 180 degrees.
So when you reflect off a more dense surface, there's a flip, okay? There's a wavelength change. You lose a wavelength somewhere. Just goes away. It takes time, is I guess the point. It takes a certain amount of time for the light to reflect. So I would argue that's the time it takes to reflect is the time it takes to deflect through a proton or something like that. But there's a wavelength change, a phase shift.
The intensity of the light that is reflected is then 4%. The square of this number. And if 4% is reflected, then clearly...
Now, you could argue that they have this backwards. That you would end up with the same relationship if I just said the phase shift happens whenever you hit a lighter surface. Right? Doesn't matter which one I phase shift, right? So it's kind of arbitrary. So I could argue that, no, when the light hits a denser surface, there's no phase shift. And there is a phase shift when it hits a lighter surface. And if I do that, okay, I'll end up with the same results. And probably more importantly, I'll end up with the phase shift being caused to the light that's going through the medium rather than the light reflecting off the surface. But anyway, I don't think it would matter. But anyway, it's a minor point.
96% goes through. So if this is 100, then this is 4.0, and then this is 96. So this light here hits the surface at B, the boundary between oil and air, and some of that light goes through, which I'm not interested in, and some of it comes back. And so I can calculate, again, the R value for that surface near B. which is now N2 minus N3 divided by N2 plus N3. N2 is N3, and so there is plus 0.2. So there is no flip in the E vector as it returns.
So the weird part is he's doing this, and he should duplicate the oil on water circumstance, and so water would have a 1.5 also index of refraction or whatever. So I mean, it just makes it a little deceptive not to put the water layer underneath, because he's really comparing this to colors you see when oil is on a surface.
And the fraction of the light that is reflected is again 4%. However, it is 4% of the 96%, because only 96% go through. And 4% of 96% is 3.84. When it reaches this surface here, again...
So there's no real evidence that they ever measure this, so I don't think they have any hard evidence for this exact, that they've ever done it. But anyway.
4% will be reflected, and 96% will go through. So what comes out here then ultimately is 96% of this number, which is 3.7.
Alright, so now you have two sources. You have the first source, okay, that reflected right off the surface, and you'd have to sort of say the light has to be hitting both of these surfaces. It has to be hitting where this is going to come out, and also the original place, and that these distances can't get too large, because then you'll lose the polarization. But the point is that clearly something reflects off this surface and something reflects off this bottom surface and comes back up. So you have two sources now, the stuff coming up from the bottom and the stuff that hit the surface. And all again you're going to do is say which ones are in phase. If I put a target up here, which ones will be in phase and which ones won't, and those will be the photons you see versus the ones you won't see. And they're going to have a location, you know, just on the fact that the angle of the fact that they will not be both coming up through the same tiny point. Whatever light it is, the light has a spread over an area, and there'll be places where the reflected light is out of phase and places where the reflected light is in phase with the ones that are reflecting off the surface. And so you'll create an on-off pattern again. And then the more you spread the angle at which the light hits and bounces back up, the more wider that angle gets, the wider, the narrower the lines get. Yeah, because of the fact that now that's when you get into this thing of the more you can have more angles that you're shooting the light in, and therefore creating internal reflections that are reflecting off where the photons are hitting, like the one that hits the surface versus the one that's coming back up. You really have to put them on some angle to really understand how they can match with each other. But anyway, you'll end up with a pattern that's essentially the bullseye pattern, and sometimes you'll just see it as straight lines, but that's only because the bullseye is so big you're only imaging a tiny portion of it. But anyway, maybe we'll save this for some other time, because it's not really slit experiment, and then we'll go back to this when we're done doing slits. So we'll play his video where he's doing the single slit and the multi-slit to see the same, that these are all the same arguments, and that's just the way they're presenting it. So it's always this. It's always just a, this is all the slits have to do with is, simple lines from the point sources. You have 2 point sources, you're just drawing 2 lines, and you're just saying, are they in phase or out of phase? Nothing else happening. Alright, so till the next time and such. I guess I should have fixed the camera, but it really doesn't matter that much. It really doesn't. So till the next time and such, and so forth and whatnot. Uh-oh. Looks like we had a problem of some kind.